Okay, I thought I would show off some of my laboratory setup here. So I have a simulated power line. It is attached to a 6-volt power supply. It's a 6-volt AC power supply at 60 hertz. And that power supply I've got attached to some resistors. So there should be about 1.5 amps flowing through this wire here. And then down here, this is just part of this sort of fixture. We have sort of this metal conductor. So what we're going to do is we're going to put a current on this line, 1.5 amps. There might already be on the line. We'll confirm it with this oscilloscope here, and then we'll look and see how much voltage is induced on this individual sort of piece of metal here. So I have this oscilloscope. It is grounded, so we can see that when I touch this thing here, the voltage peak to peak is 14 volts. So, you know, it's not quite 6 volts, but it's not the world's greatest power supply. But you can see, right, you know, there is current flowing through. There's a voltage, 60 hertz, right? So now what we can do is check this out. So we can instead of touching the wire, which we were touching here, the conductor that has the current, we can touch this piece of metal, and we can see, let's get it. Quite holding it still here. There we go. So we can see about 720 or 800 millivolts. If I can hold it consistently here, it's hard to hold the camera and so we can see about, you know, voltage peak to peak, about 800 millivolts. Total voltage about, I don't know, 480 or so. You can see there is a 60 hertz. Sorry, it's kind of bouncing because I'm having a hard time holding it still. But you can see it's about 800 millivolts peak to peak. But there is current being induced. You know, there's no other way. You know, it's probably traveling. You know, the point of, you know, is it being induced sort of via the math here is complicated, right? Because there's sort of complicated angles, but you can see that it is. Oops, stop for a second there. There is a current being induced. Anyway, that's all.